Okay, so we've talked about fractions. It's time to talk about a couple of little stragglers out there. The easy one to talk about is decimals. I say easy because decimals go into any simple calculator rather quickly. They can be done. The key to understanding decimals comes down to actually the key if this was a more basic class and we took more time with whole numbers, it's actually the key to whole numbers as well. It comes down to place value. So let's step apparently my tongue left for the night too. Let's step back a little bit and look at our whole number place values first. So at the end of the number, what's this last place value called? The ones. The next one, tens, and then hundreds. And that's actually our only three place values. They're repeated over and over again. Ones, tens, hundreds. Ones, tens, hundreds. This first group is our base group. The next group is called the thousands group. And then the millions group. And billions and so on. When you name a place value, you name its place value and its group. So this one is just the tens place. This is the 10,000s, 10 millions, and so on. Now we're not going to step back as far as like actually name numbers, but I am going to put in the numerical equivalent here. Go 1, 10, 100, 1,000, 10,000, 100,000, and we can stop there. We notice here, whenever we move one place value to the right, what happens to the numerical value of that place value? It loses a 0, or it's divided by 10. From 1,000 to 100, it's divided by 10. From 100 to 10 is divided by 10. From 10 to 1 is divided by 10. Our decimals then keep going. We put a decimal point in there to signify the end of the number, and then we keep going. Well, that pattern, if you guys stick around my classes long enough, you'll start to understand math is all about patterns. And once you see the patterns, the calculations and everything else not only make more sense, they become relatively easy. Well, here's one of our patterns. Every time we move to the right a place value, we divide by 10. So if we move to the right another place value here, we have to divide by 10 again. What is 1 divided by 10? 1/10. Dividing by 10 again would be 1/100th, and 1/1000th, and 1/10,000th, and so on. As you look at those place values, you might be thinking those look suspiciously like fractions, and they are. Decimals are nothing more than a shortcut way of writing some very specific fractions. 0.64 is 64 hundredths. The denominator of the fraction is the place value of the last digit of that decimal. In fact, it's that simple to convert a decimal into a fraction. Now, of course, we wouldn't leave it as 64 over 100 because both of them can be reduced by what? 2 would work. What's 64 divided by 2? 32. What's 100 divided by 2? 50. Are we done? No. Both of those can be divided by 2 again. Good. 32 divided by 2? 16. Good. And 50 divided by 2? 25. So there it is. 0.64 is equivalent to 16/25. we might have 0.0375. What's that going to be as a fraction? 375 over 10,000. Tenths, hundredths, thousandths, 10,000. A quick way to double check that, by the way, how many decimal places are there here? 4. How many zeros are in the denominator? 4. Now, both of those can be divided by what? 5 will work. The top one ends in 5, so it can be divided by 10. 375 divided by 5 is 75. 10,000 divided by 5? 2,000. Both of those can still be divided by 5. 75 divided by 5 is 15. 2,000 divided by 5 is 400. They can still be divided by 5. 15 divided by 5 is 3. 400 divided by 5, 80. So 0.0375 is 3/80. At this point, by the way, we could have divided both of those by 125. Would have came out. But as you can see, we don't have to have that greatest common number. We can just divide by smaller numbers until we get to where we're done. What if we had 3.58 like that? Yeah, exactly. This is just a mixed number. The part in front of the decimal point is the whole number, 3. The part after the decimal point is the fraction. That is 58 over tenths, hundredths is 100th. Now, of course, we can still simplify that by doing what? Divide by 2. Very good. 58 divided by 2? 29. 100 divided by 2? 50. Am I done? What am I missing? The 3. Got to remember the whole number. Any questions? Okay. Our operations with our decimals, we're going to fly through a little bit quickly. If I have 2.37 plus 15.8, what have we been taught that we have to do? Line up the decimal points. So 2.37, the decimal point on the bottom number has to be in the same spot. So that's 15.8, like that. The reason for that, we said before, when we add or subtract, we can only combine things that have the same name. Well, each of these digits has a place value. I can only combine tenths with other tenths. I can only combine ones with other ones. So lining up the decimal points is just guaranteeing that when I add or subtract, I am only combining things that have the same name or the same place value. Now I should fill in that missing decimal place there to avoid confusions. Let's put in a 0. And now I can just add. I'm going to pretty much ignore the decimal point except for one little thing. 7 plus 0 is 7. 3 plus 8, 11. So 1, carry the 1. Notice the decimal point doesn't affect my carrying at all. Now before I can do the 1, 2, and 5, I do need to move down the decimal point. We'll talk about why we did that in just a second. 1, 2, and 5, 8, and then of course 1. When we move that decimal point down, it's again following a pattern established by fractions and whole numbers. When we add or subtract, we keep the same name. For fractions, we kept the common denominator. Inches plus inches, we kept inches. Well, the same here. 37 hundredths plus 80 hundredths better give us hundredths. Moving that decimal straight down is just keeping that same name. When we subtract, $18.7 plus 9.42, we have to make sure we do the same thing, lining up that decimal point. Now again, we have to fill in that missing decimal place there with a 0. Now we go to subtract. 0 minus 2, of course, can't be done, so we need to borrow from the 7. That'll become a 6. The 0 is now 10. 10 minus 2, 8. 6 minus 4, 2. Drop the decimal point, bring the decimal point down. 8 minus 9. Can't do it. Got to borrow from the 1, make that a 0. This is now an 18. 18 minus 9 is 9. Notice the decimal point does not affect our borrowing or anything else. We just have to remember to bring it straight down. One more example of subtraction I want to make sure I show you. Looks like this. Something like that. 8 minus 2.3784. Where's the decimal point in the 8? At the end of the number. If there's no decimal point there, it goes at the end. So I have to line that up with the 2.3784. And I do have to fill in those missing decimal places with zeros. Now, when I go to subtract, as always, I start at the right and I work my way back to the left. 0 minus 4 can't be done. So I need to borrow. But there's nothing to borrow here, is there? So I have to keep going until there's something to borrow from. I have to go all the way up here to the 8. I borrow 1 from it, and that becomes 7. This becomes 10. Well, I need it to get way down here. So I have to keep going with it. I'm going to borrow from the 10. That becomes a 9. This 0 now becomes a 10. I have to keep going. Borrow from that 10 to become a 9. This 0 becomes a 10. Borrow from that 10 to become a 9. This 0 becomes a 10. Now we can subtract. 10 minus 4, 6. 9 minus 8, 1. 9 minus 7, 2. 9 minus 3, 6. Decimal point comes down. 7 minus 2 is 5. In business, finance, and accounting, and obviously here in business math, a very common calculation is something like this. Very similar to what we just did. So that's our 1. We have to put the decimal point after it. 0.8235. And we do have to put in those missing decimal places. Tell me what to do. Borrow from the 1. That's now 0. 10. Borrow, that's 9. 10. Borrow, that's 9. 10. Borrow, that's 9 and 10. Now we can subtract. 10 minus 5 is 5. 9 minus 3, 6. 9 minus 2, 7. And 9 minus 8, 1. Bring down the decimal. Now, I get asked this one all the time. Do I have to put the 0 here? Well, technically, mathematically, the answer is no. But practically, the answer is yes. If you were at WITC in one of our medical programs, like nursing or medical assistant, if you don't put that 0 there, they will mark it wrong. The reason for that, looking at that, was that 0.2 or is that a stray mark in front of the 2? If there's a 0 in front of it, There's no reason there would be a 0 in front of a 2 unless that is a decimal point. So putting that 0 in front just makes sure that it's very clear that there is a decimal point there. Since we're on the topic of decimal points, there is something I should mention. Most of you are business students, or some of you may be law enforcement or early childhood. But if you're in business and you have any sort of international exposure at all, you'll run into this. We're used to a number being written like this. If that were dollars, we'd be calling that $43,218.16. Many foreign countries do not use a period as a decimal point. There are many foreign countries that use a comma to mark the decimal location. Notice, instead of a comma here, all we had was an extra space. Now in this class, and in everything you do at WITC, you're going to have decimal points, periods for decimal points. But I wanted to point that out to you, that you may see that. I worked as an engineer before I came here, and up until a couple of years ago, I still did a lot of consulting work. And many of the companies I worked for have started to go international. And some of the work they get coming in from overseas, you're going to see it denoted like that. So if you work for a company that does any sort of importing and exporting, you probably will run into that notation at some point. Multiplying decimals. Something like 3.84 times 5.2. In fact, I'm going to move down a little bit here. When we multiply decimals, we totally ignore the decimal point. In fact, you can see I didn't even bother to line up the decimal point here. The reason being is when we multiply and when we divide, we don't need the same name. So we don't have to worry about lining up the decimal point. Now, when we multiply, do long multiplication, little review for us, we always start with the last digit of the bottom number, which is the 2 here, and we multiply every digit of the top number by it. So 2 times 4 is 8. 2 times 8, 16. Now we can't have 2 digits here, so it's 6, and we'll carry the 1. 2 times 3 is 6, plus 1 is 7. Before we move over to the next digit, yeah, somebody said it there, we have to put in a 0. Some textbooks might say just leave a blank spot and move over a spot, but the 0 kind of makes clear that we can't put anything in there. Now we do the 5. Now, when I put in that 0, I also come up here and I put a line above here. What that does for me is it helps me keep track of what's a new carry and what's an old carry. I now know that that 1 is old. I'm not going to worry about it anymore. Now I've got 5 times 4 is 20. So I'm going to keep the 0, carry the 2. Notice I put it above the line so I know it's new. 5 times 8, 40, plus 2 is 42. So 2, carry the 4. 5 times 3, 15. The 4 is above the line, so plus 4 is 19. So 9, I carry the 1. There's no place to carry it, so I'm just going to put it over. Now we can add stuff together here. 8 and 0 is 8. 6 and 0, 6, 7 and 2, 9. 9 is 9 and 1. Now, here's the million-dollar question. Which 9? Between the 9s. Okay. The decimal point goes between the 9s. Why? Okay. We have been taught you count 1, 2, 3 decimal places in the problem. You got to go back to your answer. 1, 2, 3 decimal places in your answer. The reason for that, this is, of course, hundredths, right? This is tenths. Remember, when we multiply, we combine the names. What's hundredths times tenths? Thousandths. Our answer has to be in thousandths. Now, another thing I usually preach if I'm doing a class where we have to, go through whole numbers and stuff, I always preach, before you punch it in the calculator, have an estimate, an idea of what you expect the answer to be. Here, this is about 4. 3.8 is close to 4. 5.2 is close to 5, right? What is 4 times 5? 20. So I can reasonably expect my answer to be pretty close to 20, can't I? Would it make sense to put my decimal point there? No, 1.9 is nowhere near 20. Would it make sense at all to put my decimal point there? No, 199 is nowhere near 20. So that position right there is the only place that even makes sense to put my decimal point. Dividing by decimals? Not as bad as it sounds. 38.27 divided by, let's go 2.4. How do we divide by a decimal? Well, it's kind of the same answer as how do we divide by a fraction. We don't. What do we do to it? Yeah, we make it a whole number by moving that over one spot. If it was 2 decimal places, we'd move it over 2 spots. So that becomes 24. When we do that, though, what else do we have to do? Move that one over. So that's 382.7 now. The reason we are able to do that, fractions and division are kind of interchangeable. I can think of that as 38.27 over 2.4 as a fraction. And as a fraction, I can multiply the top and bottom. I can multiply numerator and denominator by the same thing. If I want to get rid of that decimal point, I have to multiply by 10 there. Well, if I multiply the denominator by 10, I have to multiply the numerator by 10. So that's 382.7. So when I move over those decimal points, this is all I'm really doing, is I am using that unity fraction to rename my fraction, multiplying by 10 on top and bottom. Let's say I ask for this to the nearest cent. What place value is implied by cent? Hundredth, right? Two decimal places. So let's do our calculation. Just 20, you tried. 24, does 24 go into 3? No, so I'm going to leave it blank above the 3. Does 24 go into 38? Yes, it's once. So 8 was the last digit I used, the 1 goes above the 8. 1 times 24 is 24. We're going to subtract here. 8 minus 4 is 4, 3 minus 2 is 1. We should always double check to make sure this number here that's left over is smaller than what we're dividing by. If it's bigger, well, then we have to go back and adjust what we just divided. Now I bring down my next digit here, which will be 2. Does 24 go into 142? Yeah, it only goes 5 times, doesn't it? 5 times 24 is 120. We subtract, get 22. What must I do before I can bring down that 7? Bring up the decimal point. I don't have to do anything with the decimal point, but I can't pass it without moving it up into my answer. Now I bring down the 7. 24 into 227 is 9. 9 times 24 is 216. Leaves us with 11. No more digits. Are we done yet? No, we can keep going, actually, by just adding zeros and bringing it down. 24 into 110 is going to be 4. 4 times 24 is 96. Leaves us with 14. Now we're at the 100th. Does that mean we're done? No. We have to put another 0 in and bring it down. It's 24 going to 140. 5 times. 5 times 24 is 120. I should have wrote a little smaller so I didn't have to scroll up now. I don't care what's left over there. All I care is what's up here right now. I had to go, even though I was only going to the 100th, I had to go 1 digit past to tell me how to round. That 5 tells me that this is not going to stay 15.94. It has to be rounded to 15.95. Because this next digit was a 5 or larger, we have to round this last one up. Now, the good news is these things exist. So realistically, I don't do long division with decimals by hand. And you'll learn throughout the course that I actually like calculating without a calculator. But something like this, I would be punching in 38.27 divided by 2.4. And getting the 15.9458. After round to that second decimal place, the next one is a 5, so it tells me rounds that up to a 5. So 15.95. Does that make sense? Everybody's good with rounding with decimals? Okay. Our last thing to fill out the end of the first class, or first day, is something called integers. Integers means negative numbers. Now, to work with integers, it's not as tough as it sounds, but it does require that we step back a little bit and look at what it really means to add, subtract, multiply, and divide with positive numbers. So if we have, well, first of all, how do we represent a number? And we talked about a count and a name, like 7 inches, having to have the label with the number. For right now, all we're going to talk about is the count. We're talking about combining that count. That count of 7 is represented on a number line. Pretend these are evenly spaced again. One way we can represent a value on the number line is just putting a dot at 7. Well, if we just put a dot at 7, that doesn't do much for us. If we're just trying to represent the value, that's fine. But if we're going to do anything with it, that's not a very useful representation. A more useful representation is something called a vector. A vector is a really fancy word for a pretty simple concept. It's just an arrow. It starts at 0 and goes to the number. In this case, it goes to 7. There's my vector for 7. If I had -3, its vector would start at 0, go to -3, like that. The process of addition is just combining vectors. That's actually its literal definition if you go into number theory. So if I have 5 plus 3, what that's telling me to do is take that vector for 5, take the vector for 3, and I'm going to combine them. By combining them, it actually means you're going to take the one vector and you're going to move it end to end, head to tail is the phrase, with the other. If I combine the vectors for 5 and 3, what I end up with is a long vector that goes all the way up to 8. 5 plus 3 is 8. Well, we kind of knew that without drawing that picture. But what if the problem was 5 plus a negative 3? Negative 3 starts at 0 and goes to negative 3, like that. Well, we would take that vector and combine it with our 5. My scale's a little off here. We end up at 2. 5 plus negative 3 is 2. Now, I'm not proposing you draw out a number line when you add numbers. But when I add my integers, I do keep that picture in the back of my mind. If I have something like 17 plus a negative 31, I'm looking at this. Here's 0. Positive 17 goes that way. Negative 31 being negative goes the opposite direction, doesn't it? Is it longer or shorter than 17? It's longer. That's what we call that having a larger magnitude. So since it's longer, it goes past 0. So what this tells me about my answer, first of all, is I'm on the negative side. So my answer is going to be negative. The second thing it tells me is, since my vectors go in opposite directions, the magnitude of my answer is the difference in the lengths of the vectors, the difference in the magnitudes. What's the difference between 17 and 31? You got it, 14. So my answer is a negative 14. I might also have like a negative 12 plus a negative 9. So again, I have 0. Negative 12 goes this way. Does negative 9 go the same or the opposite direction? Same. So this one obviously ends up on the negative side. Since the vectors point in the same direction, the magnitudes combine. 9 plus 12 is 21. So negative 21. Or I might have a negative 13 plus 20. Start at 0, and negative 13 goes to the negative direction. 20 goes same or opposite? Opposite, because it's positive. Shorter or longer? Longer, so it goes past 0. So that's telling me my answer is negative or positive? Positive. Do I add the magnitudes or subtract them? Subtract them. They go opposite directions. So my magnitude of my answer is the difference in the length of the vectors, difference in the magnitude. What's the difference between 13 and 20? 7. So those vectors help me decide whether I'm really adding or subtracting the values and whether my answer is positive or negative. Now, when we go to subtraction, it gets a little tricky. Subtraction is where we usually have some problems. And the reason for that, as I mentioned it in the first hour, addition and subtraction are really the same operation. Subtraction is the inverse or the reverse of addition. It undoes addition. If I asked you to draw a picture with vectors for 8 minus 3, it would most likely look something like this. There's 8 minus 3 puts us at 5, right? We all knew 8 minus 3 is 5. But if we look at that picture looks suspiciously like 8 plus a negative 3. And it is. The reason being is the technical definition of subtraction. We think of it as being the reverse of addition. But now remember, we said an operation operates on the number that comes after it. That subtraction operates on the 3. So the 8 is never going to change. But what that symbol means, the subtraction symbol means, is add the opposite. Now I said it's operating on the 3. So the 8 doesn't change. Subtracting 3 is telling us add the opposite of 3. Well, what's the opposite of 3? Negative 3. Now, when it's positive numbers like 8 minus 3, I wouldn't change it. We know 8 minus 3 is 5. But if it's something like negative 17 minus 24, that's a bit more confusing. So I'm going to change it. Does the negative 17 change? No. The minus 24 is going to become plus. The opposite of 24 is negative 24. Now that's telling me negative 17, negative 24. My answer is negative. They both go the same direction. 17 and 24 makes 41. Or I might have 18 minus negative 9. The 18 doesn't change. Minus the negative 9 becomes plus positive 9. Yeah. We're going to add the opposite. Well, the opposite of negative 9 is positive 9. Well, 18 plus 9 is just 27. Does that make sense? Okay. No. Kind of. You got to be careful there because you can run into problems like this. Negative 13 minus negative 6. The negative 13 won't change, but this does become plus a positive 6. But still negative 13, positive 6, still ends up on the negative side. It's still going to be a negative 7. So you do have to be very careful about that. 2 negatives makes a positive. It's not a hard and fast rule. Multiplication and division is the spot where what you were saying is true. If I'm multiplying, 5 times 3, of course, is 15. When we were learning how to multiply, what we would have done is just do 5 plus 5 plus 5, repeated addition. So negative 5 times 3, negative 5 plus negative 5 plus negative 5, or negative 50. Makes perfect sense. If it's 5 times a negative 3, well, I can't take 5 and add it to itself negative 3 times, can I? But I can switch that around and do a negative 3 times 5. If I add negative 3 up 5 times, I get negative 50. The confusing one, negative 5 times negative 3. A negative times a negative is a positive. If we're dividing, we'll use the same pattern. 28 divided by a negative 7. Well, is that answer going to be positive or negative? Positive divided by negative is negative. What's 28 divided by 7? 4. So it's a negative 4. Negative 32 divided by negative 4. What's my answer going to be, positive or negative? Positive. A negative divided by a negative, just like a negative times a negative, must be a positive. 32 divided by 4 is 8. Okay, I think you guys get the picture. And I'm looking out at the room and seeing full across everybody's forehead. So we're going to call it a night there. The 2 things you must have done by next Wednesday. Make sure you are registered and up and running in My Math Lab. If you don't have that done, the second part won't be possible. That is homework number 1 in My Math Lab is also part of your assignment for next Wednesday. Make sure you do that. If not tonight, tomorrow. Get that done soon so that if you have any problems with it, you can get a hold of me and we can get it figured out for you so you can get enrolled in it so that you have time to get the homework done by next Wednesday. Like I said, there is a 50% penalty for late work. Okay. You guys have a good night. If you want to, here in Rice Lake, the computer lab next door is open. If you want to go try and register over there, you can. At the other locations, they told me that the computer labs may or may not be open past 7, so I don't know if you can find anything there, but you can contact me tomorrow if you need help getting set up in my math lab.
You go to